We're looking at the quadratics that are in this 1-1 through 1-3 practice. Thanks for joining us. Feel free to take a note of what I'm doing here. There were a variety of techniques we saw throughout Unit 1 so far. The first one that we'll look at, and honestly, all the ones I'm going to show today are just for quadratics, so I hope you're prepared for those. If I had to look at this, I just think, wouldn't it be convenient if this little, we'll call it the earring, was just relocated and it was here and built out a rectangle like that, meaning this is gone, 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 and we've now created a height of 4, width of 3, height of 5. What's the width here? Hopefully you said 4. Height of 6, width of 5. And I keep going back to figure 0 out of convenience, also because that just helps you put these equations together in a very convenient fashion. So I entertain that. Say that would have to be now 3 by 2. So your height, start with that. This is starting at 3. How much do you keep adding? Hopefully you say 1. And you do that x times because you're at figure 0. Think about that. So that's your height times your width, where what are you starting your width at? Hopefully you said 2. And you just keep adding 1 x times. And this could be cleaned up a little bit. We prefer to just have the x terms first. So you could say this is x plus 3 times x plus 2, and that equals y. And this is definitely quadratic. That's the first quadratic one. We'll see another quadratic one shortly. Problem 4. I saw a few people ask about this, a few different interpretations. My approach usually comes down to, is there some shape in the middle that I could start to poke fun at? And I do see that. What kind of shape is this? Hopefully you said a square. So if you start to nitpick that square, hopefully we can agree. At figure 1, it's a 2 by 2. At figure 2, it's a 3 by 3. Here it would be 4 by 4. And then hopefully that's enough to say that at figure 0, it should just be that 1 by 1. And this is definitely a linear progression. So your square starts at 1, and you just keep adding 1 to go to 2, then to 3, and then to 4. So this is starting at 1. You keep adding 1 x times. Since it's a square, we say it's squared. And then the other chunk, I'll color coordinate here. I'll switch to blue. I'm just going to focus in on the blue marks now. Call it the top hat and the shoes. This is 7. This is 9. This is how many? 11. So the top hat here should just be a top hat of 2, shoes of 3, which makes this all add up to 5. So this set of blue that we add on starts at 5, and we keep adding 2 x times, which is definitely quadratic because there's an x squared term in the mix. Take a moment, let that marinate. See you in the next problem. Next one, not much to really rearrange here, so I'm just going to go ahead and list the width and the height. And I'll go back to f of 0, which in theory should have width of 0. And what's the height? Hopefully you say 1. So in green, talking about the widths, this definitely starts at 0, and I keep adding 1 x times. That's for the width. And then for your height, that's starting at 1. You add 1 x times. And I didn't quite clean up the last few, so allow me to do that here in orange. You can get away with just saying this is x times x plus 1. Definitely quadratic. Shout out to those that distributed this. See you in the next problem. Next one. If I look closely, I have a square in the middle. Still the square. This is a 4 by 4, 3 by 3, 2 by 2, making f of 0, need a 1 by 1. So I would say that this is just the figure number plus 1 being squared. All of these are taking whatever the figure number is, you add 1 to it, you get the number that's there. 2 plus 1 gets you this 3, and it's a square, so I'm squaring that. I'll color coordinate for the rest. In green, doing the leftovers. In green, this is what, 7 and 2, so that makes this have 9 leftovers. This is 5 and 2, so that's 7. 3 and 2 gets you 5. That would make this, in theory, have to have top hat of 1, shoes of 2, so 3. And so I'm adding on this linear progression, which is starting at 3, I add 2, x times. Definitely quadratic. Hope that one helps. We'll look at some more. Again, a variety of ways you could approach this. Some people might reallocate this to here. I don't think that's a bad idea, because you now are able to classify this as a rectangle. So we'll get rid of that, rid of this, rid of that. So the rectangle, what are we cooking with? Height of 3, width of 4, height of 4, width of 5, height, again, just from here to here I'm talking about, of 5, width of 6. So in theory, figure 0, that rectangle should be height of 2. What's the width? Hopefully you say 3. So equation for the height. Starting at 2, I add 1 x times. For the width, starting at 3, I add 1 x times. You're getting this, right? And I'll color coordinate in orange. I have 1, 2, 3, 0 here. So I'm just adding on a linear progression of starting at 0, I add 1 x times, which is just adding on x. There you go. Quadratic. See if there's more. Oh, classic turtle problem. I see a square in the middle. Luckily, that is just the figure number by figure number square. Not 3 by 3, it's 2 by 2. So that saying way back here, this little ghost square is just 0 by 0. So this is taking, starting at 0, I add 1 x times, and just square that. And then you have what I've called the buddy bolts. 1, 2, 3, 4, all over. No matter what, you have these, so just add these on. And don't be afraid to clean this up and say that this is just x squared plus 4. Definitely quadratic. These are fun. I think I'll do one more. All right, I'll hop to 11. Here we go. What do we see? This is 3 by 3, 4 by 5. This is a 5, 7. So in theory, f of 0 should be a height of 2, width of 1. So we'll do height times the width, and then we'll lose some excess. So get ready for that. So height is starting at 2, I had 1 x times. The width starts at 1 and adds 2 x times. And then we're deducting, we'll do this in green, like Oscar the Grouch. We lose 3, 2, 1. In theory, lose 0, which is, I guess, a linear progression of starting at 0, I had 1 x times. But yeah, you can clean this up and say that this is x plus 2 times 2x plus 1 minus x equals y. Variety of ways to do all of these problems. Please be open to other interpretations. Hit me with any questions you have on if your approach works. Thanks for watching.